Hello everyone. For this tutorial video, I'd like to explain how to find the arc length of parametric curves by combining integrals of parametric curves, derivatives of parametric curves, and what we saw for the arc length earlier of more simpler functions where y is a function of x. In particular, we proved that the arc length was the integral of the square root of 1 plus the derivative squared with respect to change in x, or with respect to change in y if x is a function of y instead. So now recall that we found for parametric equations, change in x equals derivative of x over t times change in t. This means we plug this in for change in x in the arc length formula. And also remember that we found change in y over change in x for parametric curves was change in y over change in t over change of x over change of t. So we plug this into the arc length formula as well. Lastly, we remember that for the integrals of parametric curves, we are integrating with respect to t. So we change the limits from a to b to alpha to beta instead. And we have a proven formula for the arc length of a parametric curve. We can rewrite the ratio squared as the individual terms squared, but even that is very unpleasant to compute. So we will factor out 1 over a change of x with respect to t, although make sure to put absolute bars around it to indicate that it is always positive because it's a square root. And now everything in the square root simplifies to change of x with respect to t squared plus change in y with respect to t squared. And we see if we assume all of our values are positive, the absolute bars go away. Change in x over change in t cancels out. So in conclusion, the arc length in its most simplest form is, from alpha to beta, the square root of change of x over change in t squared plus change of y over change of t squared, integrated with respect to t. So now, if we want to find the arc length of this parametric curve, and we limit our t's between 0 and 2 pi, we take the integral from 0 to 2 pi of the square root of derivative of x squared plus derivative of y squared, all integrated with respect to t. We see that 3 factors out, because the square root of 9 is a common term, and the square root of 9 is 3. And we know sine squared plus cosine squared is 1, and so the square root of 1 is 1. In conclusion, the integral from 0 to 2 pi of 1 times 3 is 6 pi minus 0 is 6 pi, so that is our final answer for the arc length. Now that we have figured out 2D arc lengths of parametric curves, we can figure out surface area of solids governed by parametric curves in the next tutorial video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.